Hello everyone. We have been talking about symmetry operations. We want to visualize keenly what are we saying by this word symmetry operations. So we are considering water molecule initially. So initially we are considering water molecule. So this is a water molecule. If I put it or place it this way, you can visualize this is the oxygen. Okay, this is the first hydrogen. This is the second hydrogen. They are just similar. So let me place it this way. So we said we want to identify, for every molecule, let's identify the symmetry element and then get also the symmetry operation. So as you can see, we'll say every element, every molecule has an identity, okay? So it has an identity, E. Every molecule has an identity E. We can visualize that. It's it's similar as doing nothing to the molecule. Okay, that's why we're saying every molecule has an identity. And then for water molecule, okay, it has a C₂ rotation. Okay, so this is the proper rotation. We want to visualize that. It means, okay, let me indicate initially the principal axis. So it has a principal axis there. So that's the principal axis. The principal axis, this is the principal axis, C₂, passing through, it's an imaginary line passing through the oxygen atom. So if we have this the C₂ axis, if we rotate it by 180 degrees, I want us to visualize that. That's it, okay? So we are rotating it by 180 degrees. If you rotate it by 180 degrees, it leaves the molecule in an undistinguishable form. Okay, so that's how we visualize that. And then we said it has a reflection axis, it has a reflection plane. Okay, the XZ plane. That's simply your page paper cutting the molecule. Okay, I want us to visualize that. So we'll visualize that this way. Let me indicate this. Now let's visualize this. Okay, so it's a plane that's cutting across. Let's visualize it keenly this way. Let me put this way. We said a C₂, okay, it's a sigma, okay, it's a sigma V. So it means it's parallel to the principal axis. So it's parallel to this C₂, okay. So let's visualize that. This is the plane, okay, it's parallel. As you can see, it's parallel to the C₂, okay. So it means it cuts the molecule, it reflects the molecule, sorry. It reflects the molecule, the hydrogen to this side to be similar to this side. It will give you an identical molecule. So if you visualize it, that's how it performs, okay? So you're just reflecting, okay? Also, you'll have another molecule that is not another molecule, you'll have another plane, okay? So you'll have another plane that is X, it's YZ reflection, okay? So I want us to visualize the YZ. So let's initially visualize. Okay, let me remove these and also these. Okay, let's have the rotation. So also we said it's parallel. Okay, so the YZ reflection plane is parallel. Okay, remember the other one was cutting here. I want us to visualize that. The other one was cutting here. Okay, was cutting here. It's still parallel to the principal axis, but this other one also parallel to the principal axis, but now bisecting the two hydrogens equally. Okay, so this other one was bisecting oxygen. Okay, this one bisects the hydrogen and the oxygens together. All of these operations leaves this water molecule to be indistinguishable. Okay, it leaves it to be indistinguishable, and hence we'll conclude that water molecule will have four symmetry elements. Okay, that's identity, C₂, sigma xz plane, which is just a sigma v, and then also a sigma v prime in the yz. Okay, that's how we get to understand these. Okay, so thank you for watching. Have a lovely day. Okay, before that, sorry, maybe we should tackle a molecule and then visualize everything about the molecule. Okay, but for this case, we're just explaining what's the symmetry elements, what are the symmetry operations. That's all for this video. In the next series of videos to come, once we'll be tackling the point groups and the orders, we'll look at that in the previous videos to come. So for this video, simply just getting to understand what is a symmetry element, getting to understand what is the symmetry operation visually. Okay, so that's what we have. So thank you for watching. Have a lovely day.